So we're taking 870, and from that, we are subtracting 360. And honestly, I think we can do another 360 just by looking at the previous, because you were at 800 there. So I would say we can probably do another 360 from this. Anna, very nice, very good. Hold on here. Let me get my little calculator going. So let's see, we're doing 870 minus 360. And this is what I was talking about. Yeah, right? 510. So since they specifically are telling us that our degree measurement has to be between 0 and 360, technically, yes, 510 is also a coterminal angle, right? But since they were so specific about what the angle measurement needs to be, that's why we need to subtract 360 one more time. And that's where you're going to get the 150 from. And then this is, of course, what we were looking for. And that would be 150. Because, if we subtract another 360 from this, what's going to happen? We then actually start getting into negative angles, right? So technically, the minus 200 and yeah, Isaac, very nice. It's going to be a negative. So, and let's see, Phoenix, that looks good. Mickey, yeah, 150 was what I was looking for. Wyatt, not a problem. You could have done it without that also. No worries, buddy. All right, guys. So yeah, it would go into negative. And there are sometimes questions which will say, give one positive coterminal angle and give one negative coterminal angle. So sometimes they may ask you to give either a negative answer or a positive answer. And you can kind of see how you can get to those results. But yeah, perfect, guys. Very good. Nicely done. So that's your coterminal angle. So yeah, this is kind of what I was talking about. So they're talking about starting out with a negative 45. Now remember, to get negative angles, you need to be going in the clockwise direction. So just again, something to keep in mind as you're working through this. So you will see a positive angle is measured in the counter clockwise direction, whereas your negative angle is measured in the clockwise direction. So, Gabriel, it's not really about getting close to zero, but because in this question, they specifically wanted us to say between 0 and 360, you definitely want to make sure your number is not larger than 360. So not so much about being close to zero, but being within that range of 0 to 360 is what I was looking for. Okay, all right, very nice, guys. So here you can see with the negative 45-degree angles, and like I said, this is going to be in the clockwise direction. So you can see we are actually going down now from that horizontal axis. We're heading downward. So that gives us the negative 45. And they wanted to know, and of course, like they're saying 45 is half of 90. You want to find the coterminal angle. And this one is specifically saying find the positive angle. So for positive, of course, we need to be going in the counterclockwise direction. So you can see the definition is still going to be coterminal because they are still going to be sharing that terminal side. But since this guy said positive, you want to go in the other direction, and that's where you're basically taking negative 45 and adding, instead of subtracting, you would be adding 360 to it to get your 315 degrees. So using that same idea, can you tell me for our try it now, what would our coterminal angle look like? And again, guys, you can see it's got to be between 0 and 360, which means you are finding its positive pair. Look at that. You guys are on a roll and going so fast, I cannot even keep up with your names here. So let me see. Oh, Lord. I've got Musab, Phoenix, Marquise, Anna, Braden, Andrew, Janice, Mav, Logan. Stop, it's going too fast. Evelyn, Cara, Wyatt, Mark. Who else? Cameron, Lolly, Joshua, Isaac. That's Buckles. Mickey, don't forget your degree measurement, Isaac Mohan. And Jeff, look at you. Amazing, Alexandra. Mickey, there you go. Yeah, that's what I was looking for. Very nice. Yeah, so you guys were on a roll here. Sheesh. You take negative 300 degrees, add 360 to it, which of course 360 minus 300 would give you your 60 degrees. So that's your positive and negative coterminal angle. Gabriel, very nice. Again, don't forget your unit measurement, but otherwise that looks good. Perfect. Alrighty, guys. So you can see we have both positive and negative coterminal angles over here. Something else popped up. So Musab had a question. He wanted to know, can we not find the coterminal of a negative angle by subtracting it from 360? So Musab, what would happen is if we took the negative 45 and subtracted 360 from it, you're actually going to get a number which is going to be even smaller because, you know, you're taking two negatives. So it's not actually going to give you 315 because think about this. You are going to have, if I can get this guy working, sorry. Let me get this out here. So if you have 45, which is already negative, right? And then you subtract 360 from it, you're going to get a number smaller than that, right? So subtract, which is still coterminal. Technically, that is still a coterminal angle, but it wouldn't be a positive one, right? Because you have to change directions because what you are talking about, and let me show that to you here. So if you have this 45-degree angle over here, and we subtract 360 from it, that means you're actually still continuing in the clockwise direction. So you would be going in the clockwise direction. So that's why you would be at negative 405 instead of the positive 315. So yeah, the only way you would get 315 is if you were to add the 360 instead of subtract. Does that make sense? Yeah, good, okay. Did anybody else have a question on that with the negative and the positive angle? Okay, yeah. So if you are talking about 360 minus 45, that's actually just rearranging these guys, right? So you're just bringing the 360 in the front and you're putting the minus 45. Yeah, so that would still give you the 315. Yeah, if you just switch the order of those numbers, that would work for sure. All right, very nice. And here we come. So look at all those angles for your circle over here. So as you can see, again, we're going in the counterclockwise direction here, guys. So this is your 0 degree, right? Which also, and I'm kind of surprised they didn't write that in here, but that 0 degree also becomes 360 degrees when you make the full circle value. So of course you can see we've got our 90 degree here, 180, 270, right? As you just keep going 90, 90, 90. And then when we break the 90 into 3 parts, that's when you get the 30 and the 60 degree, which would be the same if we broke this section here into 3 equal parts. That's where you would get the 120 and the 150 from. Same thing here, 210 and 240, 300 and 330, right? They're all those breakups of the 30-degree angle in that quadrant. And then, of course, half of 90 is going to be 45. Between 90 and 180, the half is going to be 135, 225 in quadrant 3, and 315 in quadrant 4. Now, that's, again, terminology that I'm using from college algebra. So you can see if this were our, axes points. Sorry, guys, I know I'm kind of messing this up, but this section here is what we call as quadrant 1. This is quadrant 2. And again, you can see we're going in that same counterclockwise direction, quadrant 3 and quadrant 4. And that word I'm using is quadrant, right? So that's kind of how this circle is broken down. So of course, you can see we're basically looking at multiples of the angles of 30, 45, 60, and 90 degrees, because all of those are just in the different quadrants, they take on a different value. And this is going to be important because these are the same angles that we're going to be talking about in terms of radians. And that's kind of where we're headed next. So let's take a look at the radiant measurement here. So while measuring angles in degrees may be familiar, doing so often complicates matters since the unit of measurements can get in the way of calculations. So this is one of the main reasons why we use the measurement of radians. And this measure, as they're telling us, is based on the distance around the circle. So this is a distance measurement in a way, if you want to think about it. So let's take a look at how we come up with radians. So we're basically talking about the arc length is the length of an arc, you know, the arc that you see in the red color here in the diagram, which is basically made by taking your initial side of the angle and the terminal side of the angle. And they're calling it basically, it's the length of an arc S along the circle of a radius r, which is subtended or drawn out by an angle theta. But like I said, think of it as the initial and the terminal sides of your angle. And then wherever that angle forms, the circumference of that part of the circle is what we're calling as the arc. And then we're talking about arc lengths over here. Now, this is where we get a little bit into the calculation part, guys. So just bear along with me. So the arc length of a circle is basically going to be, like I said, the part of your circumference of the circle. Now, again, your basic circumference for the entire circle is this equation here. The circumference equals 2 pi r. And then, of course, we know radius is what's going to keep changing. 2 pi is going to be your constant number. And of course, you know, with pi, we go with the 3.14 and then all of those millions of digits after that. So it's still going to be a constant number and r is going to be the variable in this case. So regardless of the radius size, we're just saying that this ratio of, you know, the 2 pi is always going to be the same, just like we work with degrees. You know, degrees is not based on the ratio of a the radius of a circle. So that idea still stays the same. Now, the concept here that comes into play is, you know, you can see we have two circles over here. One of them has a radius 2, the other one has a radius 3. So once we put that into our little formula here, radius 2 circle will basically end up having a circumference of 4 pi. A radius 3 circle will end up having a circumference of 6 pi. Now, they're talking about drawing a 45-degree angle on both of those circles, and you can see that again in the image right over here. Now, if you want to break this up into, as they're showing, into, sorry, hold on. Let me move my screen a little bit. For some reason, my little chat window is blocking. There we go. All righty. So we're basically saying your 45-degree angle is breaking up your circle into 1/8, right? You're breaking the circle into 1/8 of the entire circle. So this is where they're talking about, if you take that 1/8 with that 4 pi circle, it breaks down to 1/2 pi. If we take that 1/8 with a 6 pi circle, it breaks it down into 3/4 of a pi. And you can see what happens is basically our ratio is still staying the same. They're saying now what happens if we find the ratio of the arc length divided by the ratio of the circle. So if you take that 1/2 pi divided by the ratio, which sorry, I keep saying ratio, divided by the radius, you will see that gives us a value of 1/4 pi. When you take this guy over here, 3/4 of a pi, divided by its radius, you still end up getting the same exact value. So yeah, your ratio of your circle is still going to stay the same no matter what the radius of your circle is going to be. And that is one of the reasons why we like using radians instead of degrees, because radians do not have a unit of measurement. Because again, you know, we're just talking about in how many parts you're basically breaking up that circle as. So it depends on the angle. And basically this idea of a radian is helping us define the measure of an angle based on the arc length. So we'll build up on this again next time, guys, because like I said, radians is going to be a big part of what we're doing here. Hold on a second. Phoenix has a question. So 2 pi r times 45 over 360, for example, for arc length. Yeah, so Phoenix, yes, there is a correlation obviously between working with degrees and working with radians. So there's definitely going to be like a conversion in a way that can go back and forth between the two angles. So you'll definitely see that. And hopefully we'll get to that part next time, once we kind of have a base for our radians over here. So we'll break that down a little bit. And then as I was mentioning, you can see there is that overlap between the measurements between the radians and degrees. So we'll pick up from the radian measurement here, guys. In the meantime, if you have any questions, I'll be more than happy to stay back and answer any questions. So obviously Monday is the Labor Day holiday, so I guess we'll be meeting next Wednesday. And we'll just have one class next week. Try to do whatever homework you are comfortable doing. Do a little bit every day so that way you don't fall too far behind. And then, yeah, I'm here if you guys have questions. So enjoy your long weekend, guys, and I will see you next Wednesday. Take care, everyone. Be careful. Bye, guys.